Ever wondered how computers that are faster than the speed of thought shape the way we write code today? High-performance computing didn't just change how we do calculations, it transformed programming itself. Let's dive into the thrilling world where raw computing power meets genius coding. First things first, what is high-performance computing, or HPC? It's when computers work together to solve problems so complex that your regular laptop would take centuries to finish. Think weather simulations, scientific research, and even predicting the stock market. HPC means crunching through mountains of data in the blink of an eye. High-performance computing didn't just stay in the science labs. It's influenced the very way programming languages were developed and used. Early languages like Fortran were designed to harness the raw power of supercomputers, optimizing performance for massive calculations. And in today's world, Python, a high-level language, is taking advantage of HPC's advancements with libraries like NumPy and TensorFlow, allowing programmers to write code that works efficiently even with massive datasets. One of the most game-changing aspects of HPC is parallel computing. Imagine trying to solve a puzzle, but instead of one person working on it, you have a team, each solving a piece at the same time. That's how parallel computing works, using multiple processes to solve different parts of a problem at once. This changed how programmers think. Instead of writing code for one processor, developers had to start thinking about how to break their problems into smaller, parallel tasks. HPC wasn't just about speed, it reshaped how we think about writing code. With massive computational power came the need for new programming paradigms. Developers needed to create algorithms that could efficiently utilize all of that power. This led to the rise of 1. Distributed computing, breaking tasks across networks of computers. 2. Parallel programming, writing code that runs multiple processes at the same time. 3. Asynchronous programming, letting code execute without waiting for everything else to finish. These approaches are now standard in many types of software development, from web applications to AI. Let's talk about some jaw-dropping examples. Without high-performance computing, we wouldn't have modern weather forecasting, advanced artificial intelligence, or even large-scale simulations for things like climate change or pharmaceutical research. The coding behind these systems is complex, leveraging HPC's speed and capability to process billions of calculations in seconds. This requires programmers to think not just about writing code but writing efficient code. So, what's next? With advancements like quantum computing on the horizon, the world of high-performance computing is about to get even faster. And that means programming will have to evolve once again. Future languages and paradigms will focus even more on efficiency and scalability, pushing the boundaries of what's possible. The future is about thinking beyond the limits of individual computers. It's about programming for systems that can solve problems we haven't even imagined yet. Next time you see a weather forecast or hear about a new breakthrough in AI, just remember, the magic behind the scenes is powered by high-performance computing, and it all comes down to the code. If you're fascinated by the intersection of coding and technology, smash that like button and subscribe for more deep dives into the future of programming.